Imagine you already know what's the number of significant figures in a number, but you want to do some operation on that number. For example, you want to add it to another number or multiply it by another number. The question is that what is the number of significant figures in a resultant number? Let's look at some of the rules we have here. As a general rule of thumb, if you have some numbers with some certain precision and you do some operation on them, you cannot expect to get higher precision after doing operations. That's why the result of the operation cannot have higher precision compared to the original numbers. That's an important point to remember. Now let's look at some examples. First, let's see how we can find the result if you're adding or subtracting two numbers. For this kind of operation, we focus on number of digits after decimal point. Basically what we are doing would be to look at the numbers given to us and look at the least reliable number. Least reliable number is the number with the less number of the digits after decimal point. The number you get after operation should have the same number of digits after decimal point as the least reliable number given to you. Let's look at some examples to make it more clear. For example, in the first here, we have 1200.0 centimeter plus 12.24 centimeter. Notice that for the first number, because we have decimal points, we have 5 significant figures, and second number has only 4 significant figures. First, I'm going to add them together, and the result would be 12.24 centimeters. Now we have to make sure that we have a right precision in the final answer. As we said, when we are adding two numbers, we have to first identify what is the least reliable number. We said that the least reliable number would be the number with the least number of digits after decimal points. The first number have 1 digit after decimal point. The second number have 2 digits after the decimal point. That's why the first number would be the least reliable one, which means that we have to keep only 1 digit after decimal point even in the final answer. We already have 2 digits here, and we only need to keep 1 digit after decimal point, which means that we have to round off this number to the closest number. Because the next digit after 2 is 4, which is less than 5, we need to just drop 4, and the final answer would be 12.2. As you can see, we only have 1 digit after decimal point. Look at the next number. For the next example, we have 57.23 with 4 significant figures, minus 273.2 with another 4 significant figures, plus 69 with 2 significant figures. If I just do this calculation, we end up to have negative 146.97. Now we're going to look at the precision. First, we're going to find the least reliable number here, and that's a number with the least number of the digits after decimal point. First one has 2 digits, next one has only 1 digit, and the next one has no digit after decimal point, which means that the least reliable one would be 69. We want to have number of digits after decimal point to be the same as least reliable number, which is basically no digit after decimal point, which means that we have to get it off 97 here after decimal point. But we cannot just drop 97 because we want to round off the number to the closest number. So because the last digit you want to keep here would be 6, and the next digit after that would be 9, we're going to round it up to 7. So the final answer would be negative 147 degrees of Celsius. How about multiplication and division? The rule would be slightly different when we talk about multiplication and division. In that case, we focus on number of significant figures. The result of the multiplication and division should have number of the significant figures to be the same as least number of the significant figures in the original numbers. Let's practice on this rule as well. For example, we have 1200.0 centimeter multiplied by 12.24 centimeter. First number has 5 significant figures. The zeros on the right hand side are important because we have decimal point. And next number has only 4 significant figures. If I multiply these two numbers together, what we get would be 14,688. Remember, we want to pick the least number of significant figures in the original numbers. So we had 5 and 4. That's why we have to keep only 4 significant figures in the final answer. I'm going to start from the left-hand side and keep the important figures. So here we keep 1, 4, 6, and 8, which means that we have to get it off 8. We cannot just drop 8. We need to round it off to the closest number. The last digit I want to keep would be 8, and the next digit after that would be also 8. So we have to round it up to closest number, which is 14,690 centimeter. Notice that this whole number has no decimal point. That's why zeros on the right-hand side of the number are not significant. As a result, we only have 4 significant figures as we expected. Look at the next one. For the next one, we have 57.23 with 4 significant figures, multiplied by 273.2 with another 4 significant figures, divided by 69, which has only 2 significant figures. If I look at this operation, the result would be this big number here. I have like 3 dots here because there are more digits if you put these numbers in the calculator. But we said that we have to pick the least number of significant figures in the original numbers, which is basically the 1, 4, 6, and 9. We have only 2 significant figures for that number, which means that from the last number, or from the result of this operation, we only need to keep 2 significant figures. We always start from the left-hand side, so we have to keep the first 2 digits, and we have to get rid of the rest. But as usual, we have to basically round it off to the closest number. Because the next digit after 2 is 6, we need to round it up. So we end up to have 230. Notice that. Again, notice that since we have a whole number, we don't count zeros on the right-hand side of the number. So we only have 2 significant figures in 230. But you might ask me, what's a practical way to keep track of significant figures when we are solving a physics problem, for example? The answer is easy. Try to keep as many significant figures as possible during calculation and only round off the final answer based on the correct number of significant figures. So you do not need to basically keep track of significant figures at every step of calculation. You can basically keep the most number of the digit you can get for the rest of calculation and only round it off properly at the end.
Hey guys, my name is Jess, the head of education here at Wise. I hope you enjoyed this video tutorial. If you want to see the complete course, please check out the link in the description. You can also go to one of our playlists to keep learning for free. If you want us to cover a specific course or a specific topic, please leave us a comment below. We post new videos every week, so don't forget to subscribe so you don't miss out on any of the new stuff.